Greetings, everyone. I'm Bryon Smith, and welcome to Enlightened Empowered Evolved. Today, I am very excited. I have a gentleman by the name of Dan R. Matthews, who is a public speaker on topics of the natural and universal laws, thought and goal setting. In addition, he is a professional copywriter with expertise in web content and articles, as well as marketing through social media, email, and direct mail. Dan holds a BA degree. He holds BA degrees in physics and English and earned a master's degree in marine biology. His research work includes physics, polymer, chemistry, and ocean ecology. One of Dan's 3 published books, Self-Help Jesus, was a #1 international bestseller on Amazon. Wow. And I could go on because there's a lot that this man has accomplished, a very distinguished, intellectually enlightened gentleman. And today is going to be a class. I'm going to be the student, so you won't hear me very much. And I know you guys will be sad because you won't hear me talking that much, but I'm going to sit back and be a student. Dan, how are you today, sir?
Excellent. How are you, Lute?
Oh, I'm doing amazing. I'm doing even better now.
Oh, that's great. And
Yes.
well, tell me what it is that we want to accomplish today.
I would like to know more about this quantum physics. I mean, what is it that we all should know more of? What can you, and I know that it's a very broad subject. I understand that it's very complex, but how can you enlighten us what we could, in this time frame about quantum physics, about
Well,
your knowledge?
Lute, what I'm going to do is kind of go through a little bit of background history of what quantum physics is, how it's different than regular physics, and how it gives us insight to the real way that the universe works. And I mean the universe. I don't just mean the machines on the earth and how rockets travel and how light gets here from the sun. It's all part of it. But it also includes how our minds function, how our thoughts function, why our thoughts are so powerful, but we know so little about them.
Wow.
How we communicate with each other, and how we're all really not just related, like we're all humans or anything like that, but
Right.
way beyond that, we are absolutely one with everything in the universe.
Wow, that's amazing.
Now, physics, what they call classical physics or Newtonian physics, was the science that existed from the early 1600s up until today. Classical physics is still very useful today because it allows us to measure things. It allows us to predict how objects behave, to tell us how chemical reactions take place, how neurons in your body carry signals from one place to another. Physics describes the world in a way that we can measure and predict.
Wow.
The the interesting thing about classical physics is it starts with some basic principles. When you're measuring things, you have to get down to what is it really that you're measuring. And the fundamental units, what they call the fundamental units in physics, are mass, distance, time, and electrical charge. That's
Mass, distance, time, and electrical charge. Okay, got it.
and everything else in physics, speed, acceleration, how a planet orbits around the sun, how rockets have to have an escape velocity to get out of the Earth's gravitational field. Everything in the world around us, in the physical world around us, can be described in terms of mass, distance, time, and electrical charge.
I'm
And be,
writing down some of this, so excuse me. I'm not trying to be rude,
no,
but
no problem.
this
I'm
is a
used to
class
being,
to me as well,
you know,
ladies and gentlemen.
yeah, Lute, I taught school from high school through university level for 17 years. So I'm really used to having people ask questions, take notes, throw
Yes,
spitwads, whatever it happens to be. Uh,
absolutely.
don't be throwing any spitwads.
No, no, I won't do that. I promise.
So those 4 units, because they're the units that are used to measure everything else, they're called, they have a property that's called fundamentally undefinable.
Well, fundamentally undefinable.
Undefinable. Well, that means that time, we can measure time in seconds and hours and weeks, and there are lots of different ways to measure time. Milliseconds and things like that for very fast moving things or very small objects. But time itself, if you look up the definition of time in a dictionary, it's a long definition and doesn't really tell you anything, because the only way you can define time is in terms of time.
Yes,
It's
like
how
on the
long it
clock.
takes. Time is how long it takes. Well, what do you mean by how long it takes? Well, that's the amount of time. Oh, we've got the same word. You can't use the same word to define itself. The same goes
Right.
for distance. The same goes for what they call mass, which we normally think of as weight. And the same thing goes for electrical charge. We don't try, physicists don't try to define those fundamental measurement properties, those characteristics. So if we start with that as a little, that's a little bit of a problem, because everything that we measure down to the minutest little piece, but we can't define what it is that we're measuring.
Wow.
So
So how do
that's
we come to an answer if we can't
yeah.
define
Well,
that?
the amazing thing is you can use those measurements, and you can use everything used. All of your terms for describing things are, when they're used correctly, can be used to make very accurate predictions about how things will behave. If you throw a ball at a certain speed straight up in the air, you know that due to the force of gravity, it's going to slow down and eventually drop back down, and you can calculate exactly how high it'll go. Or if you're going 60 miles an hour, you know that in 1 hour, you're going to travel 60 miles.
Miles. Exactly.
You can make predictions, and it's phenomenal that we can make these predictions, and we can build things like cars and bridges and airplanes and cell phones. Well, cell phones are a little different because cell phones use some quantum physics, as they function because of quantum physics. But bridges and airplanes and cars, all the things that we're used to in our everyday world, can be described very easily in terms of physics. But there are a couple things that came around uh, at the end of the 1800s, early 1900s, that became difficult to describe. One of those was the behavior of light. Now we know we get light from the sun, you have flashlights, you have all different kinds of light. In what we call visible light, there's a much broader spectrum, because it also includes radio waves, microwaves, heat, uh, ultraviolet rays, X-rays, gamma rays. There's a huge spectrum of what's called electromagnetic radiation, which in our shorthand term, we call it all light. Some of
And
it
we
we
can't
see,
see any of that.
right, some of it we can see, some of it we can't. And it turns out the amount we can see, which is we are creatures that have been created to respond to a physical environment. We can feel, hear, smell, taste, see. We have all those senses, but they're very limited. in terms of light, electromagnetic radiation, we can only see about 1/1000th of what's out there.
Wow, that's
Now, some of it we can't. We also have sensors on our body that's not our eyes. And you've all stood next to a campfire or a bonfire or an outdoor heater, and you can feel the heat energy coming off it. You can feel it on your body because your body has heat sensors. You can't see the heat energy, but you can feel it.
but you can feel it. Is that the same? Is that any connection to like wind? We can feel it, but we can't see it.
It's
And
right.
it's a force.
It's similar in a way because we can't see it because the gases that make up the wind are all clear. They're very small particles, and you cannot see air. You can see sometimes water vapor in air that makes clouds and fog and things like that, but that's condensed water vapor. But you can't see air, although you can see the effect that air has on light. You've all seen heat waves. If you're driving along a highway in the summertime, you can see those heat waves coming off the road in the distance.
Absolutely.
And that's because the air above the road is heated and starts to rise, and because it's less dense, a light beam going through it makes a kind of a wiggly path as it goes through. It kind of like a bunch of little lenses put together, and it makes it look all wiggly. There is actually moving air, and the light as it passes through makes a funny path. But it's different in a way because air molecules are randomly moving in all directions. And it's interesting that they move about 400 miles an hour. You
Air,
probably
air
you
molecules move constantly.
constantly at about 400 miles an hour. And you've been in, you wake up in the morning and you can smell the coffee, even though the coffee is being made in the kitchen and you're in the bedroom, you can smell the coffee or the bacon or whatever it happens to be. You can smell. Smells are little molecules that travel in the air, and they get pushed by air molecules. And it doesn't take very long when you're making coffee that somebody in another room can smell that coffee being made.
And that's because of how fast it travels,
Right.
400
I
miles
mean,
an hour.
those coffee smell molecules, the coffee molecules get pushed by the air and they fill up the whole room, and even pretty evenly fill up the room or move into the next room.
Wow.
But in terms of light, they found that there were some strange things that happened with light, because they always thought light was a wave, like an ocean wave. And they were right. But they were also wrong,
How so?
because it turns out that in some situations, light acts not like a wave, but it acts like a little tiny particle.
Hmm.
And when sunlight, when you're out in the sun, a sunny day, you can feel the heat from the sun. The sun's a long ways away,
Yes, it is.
almost 100 million miles away. And
Yes,
it doesn't look really that big. The sun is over 1 million times larger than the Earth.
in the earth. That's it's
Yeah,
so far away.
it has a radius. It has a radius 100 times the radius of the Earth. It's 800,000 miles across,
Wow.
and its volume is 1 million times greater than the volume of the Earth.
Now, what has always puzzled me is that when you leave Earth, now Earth can feel the effects of the sun. Now, when you leave Earth, that space between Earth and the sun is cold. Why is that?
It's cold because the light hasn't had a chance to interact with anything.
So there's nothing there.
There's still light there. Well, there is something there. There's energy there. And energy completely fills everything. Everything. Most of it we're not aware of. That's what I was leading up to. but when they saw that light sometimes acted like a particle, like little BBs or grains of sand, or it behaved differently in certain situations. And they said, well, it must also have particle properties. And they came up with a theory that light was a particle that traveled with a wave-like motion.
Even though it
And the
looks like
and
it's
the
going straight.
it moves generally in a straight line, but it's moving with a little wave-like motion, like ocean waves, because ocean waves are spread out along the surface of the water, but they move out from a point. They move out like if you throw a rock into a still pond or lake, the ripples go out from where that rock hit the water. The same
Right.
thing happens with the sun. The light spreads out evenly in all directions, and it travels with a wave-like motion. Actually, it travels it travels as a wave, not wave-like. It is a wave,
Right.
like an ocean wave, but it's not. It's what they call an electromagnetic wave. It's a particle. It's made up of trillions of little tiny particles called photons. And photons are particles of light that travel with a wave-like motion. They travel at incredibly fast speeds. The fastest we've ever traveled with our own power is when astronauts take off from the Earth and they travel to the moon, or they travel in orbit around the Earth. And those astronauts are traveling about 20,000 miles an hour, which seems huge because on Earth, 700 miles an hour is faster than almost everybody's gone.
Yes.
You've
The
traveled,
supercar is about
yeah,
that.
you've traveled at 300 or 350 miles an hour on a regular basis. Every time you get on an airplane, every time you get on
Airplane.
a jet,
Yes.
they travel about 300 miles an hour. But that astronaut traveling 20,000 miles an hour is traveling less than 1/100th of the speed of light. The light travels actually at about 100, almost 200,000 miles per second.
Wow.
Super fast,
And
186,000 miles per second.
so, in your opinion, do you think, and I'll let you continue, that we'll ever get to a point where we're able to even get remotely close to that as far as traveling?
Well, we can't, so far, no. And the reason is some strange things start to happen as you get close to the speed of light, even to say 1/100th of the speed of light. The things start to change in terms of what we think of as normal measurements of distance and mass and time. Uh, Time slows down, literally slows down. One second, if you're traveling close to the speed of light, even at 100th of the speed of light, if you're traveling like a satellite going around the Earth, they have to be synchronized to account for their rapid speed. Even though they're not traveling at really close to the speed of light, they're traveling at a significant fraction of the speed of light. Time slows down. A second for a person traveling close to the speed of light could be as much as an hour, or maybe a year or a decade, compared to a person sitting back on the Earth.
Wow. Never knew that. So,
And and things get heavier. So the faster you go, the more, what they say, the more massive you become. And distances between, if you look out a window, if you're traveling in an airplane and close to the speed of light and you look out the window, what used to be a mile maybe shrunk down to only a few meters.
I can see that. That
So
part I can kind of understand.
things things start to change, and it's all described in a it was described in 1916 by Albert Einstein, who was young at the time, and it was called the theory of special relativity, which described how things behave when they're traveling at very high speeds. And Einstein was another person who was involved in the development of quantum physics. But they found out, back to the story of the photon, they found out that photons were what they called an elemental particle. They were a fundamental basic unit of mass. And this is where Max Planck came in. He was instrumental in describing how that worked. There were some other things that they started noticing. One is, if you had a certain kind of substance that's today called a semiconductor, and light is shined on that substance, it can produce a flow of electricity. That light energy can be converted into electrical energy. And that's how all the solar cells that are on all the buildings and the houses and roofs, and some cars have them on them and all that kind of stuff, those black solar cells work by that principle. And it's called the photoelectric effect. That light, the photon, strikes the semiconductor, the solar cell, and produces a flow of electricity.
Creates,
And you
in
can use
essence,
that.
energy.
Yeah, that energy gets converted, and it's converted from light energy to electrical
Electric
energy
energy.
directly. There's some heat loss, there's also heat produced and so forth, but it works a little bit like this. Watch this. This is just a wine glass, just
Yes.
off the shelf wine glass, and it if you ding at it, you hit it with your fingernail, it makes a sound. But watch this. If I get my finger going at just the right speed,
Oh, wow.
my finger's not making a sound.
What's making the sound?
The glass is making the sound in response to the energy of my finger. It's kind of like a little picture of what the photoelectric effect is. Energy of one form, which is the energy of my finger moving, is converted into sound energy in a process called harmonic resonance. And harmonic resonance turns out to be a very important and fundamental concept, not only in quantum physics, but also in how we transfer thoughts, and how we make how people make things that they call the law of attraction is actually harmonic resonance of our thoughts with energy that's already in the universe.
And it draws it. That was going to be my next
Oh,
question.
you're
But
thinking,
how all this quantum physics and complexity, how can we, I don't want to, I want to ask the right way, but how can we, in essence, how can it benefit us of knowing certain things? How can we tap into whatever?
Well, people are interested in how do I manifest, how do I achieve a goal that I don't, I don't know how to achieve a goal. How do I achieve a goal? Well, you achieve a goal by, there's some steps, and they have to do with the laws of the universe, and very similar to the laws of physics, and applications of this whole idea of harmonic resonance. You know that if you have a thought and you have a significant other, sometimes that significant other picks up that thought before you've even said anything.
Yes.
Everybody's had that experience because you're on the same wavelength.
Absolutely.
And being on the same wavelength is a perfect description of what it actually is. Your thought goes out as energy, as electromagnetic energy, thought energy. It's a little different than electromagnetic energy, but it's thought energy, and it has many of the same properties. Goes out as waves, and those waves have a vibrational frequency. And you know that because of sound. You know about frequency, and you know about harmonics.
Yes.
Like feedback. Feedback is harmonics between your microphone and your speaker. The speaker starts to vibrate, the microphone starts to vibrate at the same frequency, and pretty soon it's going whoop, and you can make adjustments to stop that feedback. But harmonic resonance, between you and your significant other, you send out a thought, and that causes a harmonic resonance, like my finger on the glass, to happen in your significant other's mind. In her sensory system, she's not sensing anything that you can measure, but she's picking it up because her brain is a receiving station, just like a radio receiver, for thought energy.
Now, does distance have an effect on that, or it doesn't?
It does not have an effect on it. And it was shown through an experiment later in quantum physics, and it's been repeated hundreds of times everywhere in the world, called quantum entanglement. And they found that if you take what they call subatomic particles, like two little electrons that are part of the atom, sometimes those come in pairs, and they have properties. One of those properties is spin. If you think like a spinning top, or a spinning, if you take a quarter and you flick it with your finger, you can make it spin on a tabletop.
Right.
Electrons have that property also. It's actually called magnetic dipole moment, but we can just call it spin because it's very similar to that. And if one electron is spinning one way, its entangled partner spins in the opposite direction, so that the two spins cancel each other out, because nature likes to be balanced. And they found that if they separated those two electrons, and they switched the spin electrically, switched the spin on this electron, the entangled pair would switch instantly, all by itself, with nothing being done to it. And
what is it that's causing that connection?
There is a connection, and the connection also involves a transfer of information. They communicate with one another, and they thought, how does that happen? And what's the mechanism, and how fast is that signal going? So they separated they continued the experiments, taking the electrons, I'm off the screen here, taking the electrons further and further apart, until they could actually measure the amount of time it took for the signal to get from the switched electron to the paired electron. And they found it didn't matter how far apart they went, the paired electron switched instantly, faster than it could be described by the speed of light, by the signal going from one to the other at the speed of light. It was faster than the speed of light. It was instantaneous. And physicists scratched their heads and said, the only way we can describe this is it's something like thought.
So in essence, we are the same way.
Right. And we in our thoughts can transfer information from one point to another instantaneously. And many experiments have been done in the realm of thought transfer, mostly by European countries, but it's been repeated in the US also. Concrete walls have nothing to do with it. Metal boxes, two people sitting. They actually did an experiment with one of the Gemini trips when they were orbiting around the moon. They got to the backside of the moon and tried a thought experiment, and a person on Earth could receive the thought signal sent by the astronaut that was on the backside of the moon, and that thought energy had to travel through the moon and 250,000 miles to get to Earth, and it happened instantly.
Wow. Now, what I want to know, excuse me, is how could a quote average person, and I know none of us are average. We're all extraordinary. We're all extraordinary. We're all extraordinary. So that's the wrong word. But how would someone like myself purposely be able to do that? Or is it just happen unconsciously? I mean, how would I purposely be able to make that happen? Or is there something that I have to concentrate on, or certain, what would I have to do?
Tell me about the sound studio that you're sitting in. Has that always been there?
No.
No. How did it come to be?
I
What were your steps? What were the steps that you, if you remember back, how did it come to go from an empty room to a finished sound studio? What was the first step?
The first step was thinking about it.
Exactly. You put out a thought that went out into the universe and started harmonic vibration with energy in the universe, and the vibrational frequency that you had was the vision, the image that you had of a finished sound studio. And you
So
thought it'd be awesome if this sound studio had such and such a soundboard and such speakers, and I want the best Technica mic that is out there, the Audio Technica. I have a friend that works for Audio Technica.
no, I was about to say, man, I got to get you in here now, because that is the microphone right there.
It is. It's the yeah. It's the yeah. Well, I have a friend. Have you heard of the Michael Stanley Band from
Michael
Ohio?
Stanley. That's where I'm from,
Kind of a
Ohio, and I can't.
Bruce Springsteen type of band.
Oh, okay.
But Michael Stanley, this friend of mine was the sound engineer for Michael Stanley Band, but he was also a representative for Audio Technica in the U.S. And so he traveled between here and between Ohio and Japan quite a bit. But yeah, he speaks very highly of Audio Technica.
Yes, very,
Anyway,
very good equipment.
you had a vision of a finished sound studio, of including the things that you probably had it down to I want to have the soundboard's going to be here, and the things I'm going to be using are here, and the mics are going to be sitting like this, and you had it all in your mind.
Absolutely.
And there was passion in your thoughts. You really loved that idea, and you were obsessed with that idea, if I'm not mistaken.
Yes, I thought about it quite a bit.
Yeah. That's exactly how any goal is achieved. First, there's a thought. Second, you have a desire that goes with that thought, and that desire has passion, has what they call elevated emotion attached to it. You
And
you love the
sort of
idea.
charges it or energizes it.
Energizes it, increases in physics they say it increases the amplitude. And you know about amplitude because you're a sound man.
Yes.
So the amplitude is the power of the wave. It doesn't
Wow.
change the wavelength. You can have a middle C vibrating at 432 or 440, I guess, 442 hertz at middle C, and the wave can be this big, or the wave can be this big, right?
Absolutely.
Higher amplitude, the frequency stays the same. We're on the same wavelength, bro.
Oh, I want to be able to explain quantum physics like you one day.
So when you send that thought out, it causes harmonic vibration in the energy. Energy exists in the universe of all frequencies. So the particular frequency that was the image of your sound station, your sound studio, already existed out in the universe. You got in harmony. You produced energy in harmony with that frequency and caused it to start to come together. Now there are other things that have to happen. You have to take some kind of action. You have to tear some things out or build some walls, and there are some things that you have to physically do to make it happen. And you have to be persistent about it, because you could get halfway done and decide you're not interested anymore, and you've just got a room that's half finished. But if you've got the passion, you've got the obsession, you've got the energy going into the project, you made it happen by your thought energy.
And that equates to basically anything that you want in life.
Everything in life. Everything in life follows exactly the same process.
Now, my next question is, I want to go back to this thought current that we're able to pick up from the moon. How does that, I mean, how am I able to do that? I mean, I do understand that I can say a thought or think a thought, and then my my wife will pick it up, but how do I, is it, what determines the sender and the receiver? I mean, how do we do that?
We can all do it. We all have the ability to do it, but you have to believe that you can do it. You have to buy into the concept, or it'll never happen.
Yes.
It's like if I know there's a clock behind me, and if I sit just right, you don't know there's a clock like this. You don't know there's a clock there because you can't see it.
Yes.
I can't see it either, but I know that it's there. It's the
Unless
same.
someone came and
The same.
took it out.
Yeah. If I moved my head and was gone, I'd be really surprised. But I know that it's there, and
Yes.
I can be sure of that, and I can tell you that you have the ability, you have the power within you to send out a thought. Now, once you've sent that thought out, it's out in the universe. And remember, it travels instantaneously. So it goes everywhere in the universe all at the same time. And it starts harmonic vibration and starts thought energy moving. And you can change energy, just like I did with my finger in the glass. You can change energy from one form to another. Energy is always changing in form everywhere in the universe. And that particular kind of energy, when it travels from you and your wife, because you and your wife have similar receiving stations, everybody does, but you have a particular um, coherence with your wife, and she can pick up on your, maybe not specifically the thoughts, but she can say, what are you looking at that girl for? uh, Something like that.
Well,
That's
you just read my thought right now. Oh, I got to keep you away from my wife.
that's funny. But here's another little demonstration here. How things can change. Actually, I'm going to swing this around. How are we doing time wise, Luke?
We're doing great. We're doing great. We just gonna flow with this.
Okay, here we go. I've got something here that was named after a great inventor whose name was Nikola Tesla.
Yes,
And
I
now
love
there's cars.
Tesla.
Now there's cars named after him. But this is a thing called a Tesla coil. Some people might think it's something else, but it's not. Um, and when I plug this in and turn it on, it'll make a buzzing noise, and it's what's called a step-up transformer. But this was specifically invented to make very high voltage. It goes in, plugs into an outlet, but what comes out the end here is 50,000 volts.
Wait a minute, maybe you shouldn't be messing around with that thing.
Yeah, I know. But here's what happens. I plug it in, and it makes a buzzing noise. And if I take here's a little bobby pin. If I take a bobby pin and hold it close to it, I'm going to stand behind it so you can see. Watch what happens.
Wow.
Can you see that very clearly?
Yes, I can see it. Amazing.
And I'm going to wet my fingers. I've got a little bit of water here, so that I get a really good electrical contact with this 50,000 volts. It is 50,000 volts. You don't get a spark jumping. This is about an inch that spark is jumping is proof that it's 50,000 volts.
Well, why is it not doing anything to you?
That's a good question. Watch this. Now, watch this. There's a fluorescent tube right here behind me. Where is it? It's over there. Watch this fluorescent tube when I get close to it.
Oh, wow.
This is energy that's in my body right now. It's just a fluorescent tube. It's not hooked up to anything.
Yes, it's hooked up to you.
It's hooked up to me. But if I pull my hand away, this is another picture of quantum physics, because there's a gas in here that will glow when it's in harmonic resonance with another form of energy, like my hand that now has 50,000 volts on it. And
Well, why?
if I just get close to it, it starts to. I'm not touching it.
Yes, you're lighting it up.
And
Yes, I can see.
if I light it up, it becomes a lightsaber like Luke Skywalker.
Oh, wow. That's now, why isn't it doing any harm to your body or your internal organs?
Well, because my whole body has the same electrical potential on it. It's sort of like right now on your body, you have on every square inch of your body, you have air pressure that's 15 pounds per square inch. You've got about 3,000 pounds of pressure pushing on your body right now, and you're not even aware of it
Wow.
because it's pushing evenly every place. Now, something might happen to me someday
No,
because
don't say that.
I've done this fairly often, but it's interesting that is showing you that you can have energy within your body that can cause something else to show that there's energy around. And you do the same thing when you send those thoughts out. I'm going to let go of this. I have to be careful when I do it.
That's amazing. Thank you for showing that. That's absolutely amazing. I've never seen anything like that.
Yeah, there aren't too many people that would even take up the challenge if somebody said, "Would you want to hold on to this?" And I don't think so.
Yes, I'm one of them.
Yeah.
No, I appreciate that. That was absolutely awesome.
Yeah, and we're running a little short on time. So I'm gonna call it quits here, because that's a good place to end.
Let's
And
do that.
we've only cracked the surface.
Surface. Wow.
What do you
That
say?
means I'm going to have to have a few more with your permission, with your willingness. I'm going to have a part 2, a part 3 with you
Yeah,
sometime in the near future.
yeah, and one of the things that I do is I speak to groups about these kinds of topics, about thought, why thought has power, how you can use the laws of physics, the laws of quantum physics, to set goals just like you did on your sound studio, set goals and achieve goals, because the steps are the same. It doesn't matter what your goal is. And it doesn't have to be something that even exists. Steve Jobs, when he invented the cell phone, Steve Jobs only had an idea.
Right.
And he didn't know, nobody knew how it could go together. Although all of the elements have always been here. Everything to make a cell phone has always been here. They had
Yes.
to figure out how to put it together.
Yes, that's an amazing thing that when you and I know we're running short on time, but when you just look at just creations around here, like, you have to think nothing came from another planet and landed here, some care package from another planet. All this stuff came from this planet. We've just know the element, how to put it together to make it into this.
That's
Like
right.
these flat screen TVs we look at, we gotta realize that the same elements that make these TVs were here in prehistoric times. The same
Oh, yeah,
things.
yeah,
Nothing's
yeah.
changed.
Yeah, caveman could have made a cell phone and a flat screen TV, but they didn't know. All they could think about was where they were going to get their next berries.
Or next meal, yes. Or
Yeah,
running away from dinosaurs.
that's right. Yeah, yeah. Here comes a tiger. Let's get on the trail.
Let's get
Yeah,
away from there.
Lute, it's been a pleasure, and I
Yes.
really look forward to another session. We can carry on from this point. There are an infinite number of things to talk about.
Wow, I can see that. And I appreciate you coming on and taking time out of your very pressing schedule to meet with me. How was just before we go, how was your snow ski trip? How'd that go?
Snowshoeing.
Your snowshoe trip.
Snowshoeing and cross country skiing. It was great. And we have a poodle who looked like a porpoise going through the ocean. He was in this deep snow, and it was really fun. We had a good trip, and we came back from that. We spent 3 days in the mountains snowshoeing, came back and went kiteboarding the next day.
Wow. A man after my
My,
own heart, adventurous. You
my
probably
wife and I
a
both
lot more
kiteboard.
adventurous than I am. Yes.
Kiteboarding is an adventure. Snowshoeing is fun because it's pretty, but it's also kind of tiring.
Yes.
Kiteboarding is fun because it's really kind of life on the edge. It's potentially dangerous. I apologize for my cat who's been telling me she's locked in. I didn't know she was sleeping in my studio when she's telling me she wants out.
Yep, that she's telling us that's it. So
It's
thank you,
time
sir,
for
and thank you everyone for tuning in. I hope you got something out of this. I know I did, and I look forward to speaking with Mr. Matthews again. And
yeah.
I'm sure you all are. Thank you.
We'll go deeper next time.
Yes,
Yeah,
enlightened, empowered, evolved.
that's right.
Peace and love to everyone.
Thank you.